Okay, so now that we have a little bit of a stronger handle on the idea of what is meant by slope from our first two videos, let's talk about the idea of a form of equation of a line called the slope-intercept form, which gives us more information about both the slope and a point, and we can extract that information directly from the equation of a line. This is the same form of the equation of a line that has been given in the function form previously. That means that for us, if we wanted to write the equation of a line in what's called slope-intercept form, we would write the equation y is equal to the slope m times the variable x plus b. b is a number that represents the y-intercept. So in this form of the equation, we can say about it that we have m representing whatever our slope is, and b representing the y value of the y-intercept. This is our y-intercept value, which occurs at the point 0, comma, b. So let's take on this equation right here, for example. Y is equal to 2/3 times x minus 2. Right? Now the negative is actually considered part with the 2, so you could also, if it helps you to think about this, rewrite this equation as y equals 2/3 x plus the number -2. Right? And this is a useful way of thinking about it because it means that whenever we look at this line, we can now interpret it in the form of our equation y equals mx plus b to mean that our slope is 2/3 rise 2 over run 3, and our y-intercept is at the point 0, comma, b. So this is -2 right here. So if I go over here to my graph, I can plot that. Here's 0, -2. And if the slope is 2/3, that means that if I rise 2 points, so up 2, and go to the right 3, so run 3, I should find that the coordinate point 3, 0 is also on my line. And I could continue this on, but let's see how this works out for us. If we take the equation of this line and we're to actually plot it here, if my machine will let me do it, there it is. Check out that that what we just showed right here, and if I can get my rest of my drawing to cooperate with me here, it doesn't seem to like what I did right here, so I need to zoom in just a little bit. Oh, zoom in, come on. There we go. Okay. Here, I'll just erase some of this extra stuff right here so you can see. Right. We started at -2 along the y-axis. Right. And we went up 2 and to the right 3 to get to our point right here at 3, 0, rise 2, run 3. And rising 2, running 3 can work for us all the way around the line, by the way, if we liked. We could start here at the coordinate point 3, 0, as we stated before here. Let's see if I can just do this in a different color. There we go. We can start right here at 3, 0, and we could go up 2 and to the right 3 and find another point. If we go up 2, that means that our y value changes from 0 to 2, and our x value goes to the right 3. So we go 3, 4, 5, 6, 2 would be another point. And we can continue on in this vein. We would go up and have another point here at the point 9, 4. Right? And each time it involves a rise of 2 and a run of 3. Very, very useful. Since that idea of slope is so useful, it's almost as if we do not need the equation of the line in the first place to even get the picture of the line. As long as we have a point somewhere in the line and that slope, we're actually in a really good place. And let's see. Let's say that we have this line, for example, that passes the point 2, 1 and has a slope. What would it look like? Well, let's go to the point 2, 1, which is right here. Here's my coordinate, 2, 1 right here. And the slope is 2. Now, if the slope is 2, if you get a whole number for a slope, we rewrite it in fractional form, 2 over 1, which means that our rise is 2 and our run has to be 1. All right, rise 2, run 1. So rise 2, rise 2, run 1, and our next point might be found here at 3, 3, right? We could get another point if we wanted to, go up 2 to the right 1. So now we're at the point 4, 5. We could even go backwards. If we went back 1, we could go down 2 and be at the point 1, negative 1. Well, whatever the case right here, as we see, if we wanted to put in a line here along this slope right here, we're going to say go down 2 over 1, down 2 over 1, down 2 over 1. Take this line, pass it through our points, and there it is. That is the picture of the line that we're talking about right here. Now, there is actually another way of writing the equation of the line that we have not used before. Let me just really quickly give it to you here, even though we'll probably encounter it later. This is called a point slope form. And sometimes it's a really easy way just to get an equation of a line. And it says, all right, if you have a line that passes through the point x1, y1, and has a slope m, another way we can write the equation of the line is to take the variable y and subtract our given point y1 and set that equal to the slope m times the difference with the variable x minus x1, which is the given x-coordinate point. So our line that passes through the point 2, 1 and has a slope of 2 would actually be written as y minus 1 equals 2 times the quantity x, variable x, minus 2. Okay? And this is now a really quick way of getting the equation of this line. And if we were to rewrite it, we might actually find some interesting stuff. For example, y minus 1, we could simplify this and rewrite it y equals 2x minus 4. And then if we added 1 to both sides to isolate y, we put it in that function form, which we also call the slope-intercept form, y equals 2x minus 3. And right now I can tell you that my y-intercept should have been 0, negative 3, which I guess my drawing didn't quite do justice to it. It should have gone through this point over here. All right, well, I missed a little bit, but you get the idea. This is the way that our equation should look. A little bit of adjustment. There we go. There, the wonders of technology have saved us. All right, see you in the next video.